Welcome back. In this video, we're going to write our first Java program. But before we can start coding away, we need to set up an environment that is Java development friendly. To start off this process, let's download a Java development kit, or a Java SDK. This kit contains libraries and executables that allow us to do lots of different things with Java code. Most importantly, with our SDK installed, we'll be able to compile Java code and then run completed Java programs. You may already have Java installed on your machine. However, unless you've explicitly done it, you probably haven't installed a Java SDK. The version of Java your average user has installed on their machine is called the Java Runtime Environment, or JRE. This allows the execution of Java programs, and Java programs won't run on environments without the JRE installed. But the JRE doesn't contain any real development tools, which we're going to need. The good news is, a Java JRE and a Java SDK can exist harmoniously. The Java JRE is really just a subset of the SDK, and so if we only have the Java development kit installed, which we're about to download, we're also going to be fine. If you have downloaded the Java development kit in the past, when we actually go to install this kit, Java will let you know that it's already installed, and you can skip this portion of the video. For everyone else, let's download ourselves a development kit. To begin with, pause the video and navigate to this URL at the top of my web browser. Okay, we're going to be using the Java SE, or Standard Edition Development Kit, maintained by Oracle. To acquire this kit, we simply go to the Downloads tab, express that we would like the JDK, scroll down, check out the license agreement. Might be another good time to pause this video. Eventually, accept the license agreement, and then we're going to download the version of the SDK that's appropriate for our operating system. For me, that's this guy. Once your download has completed, install it as you would any other program. Choose the default options when appropriate, and make sure to take note of the directory to which you install your development kit. Okay, with our Java development kit installed, we technically have all the tools we need to start writing Java programs. However, we'd have to compile them through a command line, which can look a little different on different operating systems. So to keep everything simple, let's start learning Java by writing our Java code in an integrated development environment, or IDE. This is a software program of its own that helps us write, compile, and run Java programs. We're going to use the NetBeans IDE, which is awesome because it is free, open source, and is going to operate just about the same on Windows, Mac, and Linux environments. To acquire this IDE, head to the URL once again at the top of my web browser, and then you'll see this page. Because we've downloaded the Java Standard Edition Development Kit, that's the version of NetBeans that we're going to download here. NetBeans should start our download automatically, but if it doesn't, we can click here. Once again, we're going to install NetBeans as we would any other program, choosing default options when appropriate. Most likely, NetBeans will locate the Java development kit on our machine. If it doesn't, it will prompt you for the directory in which you installed the Java development kit. Hopefully you got NetBeans installed and booted up without any hassle. And now you're ready to write some Java code. So let's do that. We're going to go File, New Project in NetBeans and choose Java Application as our project. Make sure this Create Main Class option is unchecked, as this will create for us a essentially blank project. And give your project the name hello world. Here, you can declare what location you'd like the project's folders to live in. Once you've done that, click Finish, and NetBeans will set up a file system for us. We can navigate this file system just like we were in a standard file system explorer. The source packages file is where we'll be writing our code today. And you'll notice under this libraries file, the JDK is linked, allowing us to access all of its many library resources. All right, hopefully you got NetBeans installed and booted up without any issue, and now you're ready to write your first Java program. So let's do that. NetBeans will manage the file structure of our programs for us. But first, we need to tell NetBeans that we're ready to begin a new project. To do this, we click File, New Project, and choose a Java application. We're going to need to give our project a distinctive name. Let's call this one Hello World. And then we can choose a location to put the file. Because this is our very first Java program, we should probably start from as close to scratch as possible. So let's uncheck this Create Main Class option so that NetBeans gives us pretty much a blank project. And then we'll click Finish. You should see this Projects, Files, and Services tab like I have here. Let's look in the Files tab. Whereas the Projects tab is a bit of an abstraction, the Files tab shows us what's actually contained within the file system where our Hello World project lives. Most importantly, this source file here has no files in it. That's because there's no source code associated with our project, and so right now it won't do anything. To remedy that, let's right-click on this file, choose New, and Java class. We're going to name our Java class Hello World, just like the name of the project, because it is our main class, where the program should be entered and start from. Everything else is going to work just fine here for now, so let's click Finish. And NetBeans will create hello world.java for us. A .java file is essentially a text file, but it should only contain Java code and comments. When we told NetBeans to make this file, it took some liberties and added some code for us already. You'll notice that some of the contents of this document are completely human readable. These are what we call comments. Any text that appears in a Java file between this \* opening bracket and * closing bracket will be completely ignored by the compiler. We can write whatever we would like in here, and it will not affect how our program operates. For now, let's just delete these comments so that we can deal purely with our Java code. Java code, like the English language, is read top down and left to right. Even if our project contains many files and many classes, we still need to start reading and executing our code at a specific point. We named this file and class Hello World the same name as our project because we would like it to be special and contain the public static void main method. That's quite the mouthful of jargon. For now, just type it out and know that this is the area of our code from which our Java program will begin reading and executing. In fact, we have to add a little more jargon here. String bracket args. Once again, this will become much clearer as we begin to learn Java. Just know this is the starting point for our Java program. are followed by opening and closing brackets. One of the great things about working in an IDE is that it will highlight which brackets correspond to each other. The brackets allow us to place code within other areas of code. For example, our main method is contained within the Hello World class, and the Java code, which we're about to write and execute, is going to be contained in our main method. This line 4 right here, which currently contains nothing, will be where our program looks to start reading and executing Java code. Our goal with this Hello World program is pretty modest. When it runs, we'd like it to print some text to this output box at the bottom of our screen. When we downloaded the Java SDK, we acquired a library of useful functions, one of which will do just this. This is the println, or print line, function. When our Java code executes over this function, which it will do right away because it's the first function in our main entry point, the Java code will print some words to our output box. Functions are followed by an open and close parenthesis. Inside these parentheses, we put information that the functions need to complete their task. Println, of course, needs to know what we would like it to print. In Java, a line of text is contained by 2 double quotation marks, and we call it a string. Let's have our program print Hello World. You might have noticed that NetBeans has been yelling at us for a little bit. There's a light bulb and red dot here, and some red jittering under our text, a lot like we had made a spelling error in some text editors. And that's really what we've done. We've made a syntax mistake. There's something clearly wrong with our Java code, and NetBeans knows it. There's actually 2 things wrong. The first is that our code doesn't end with a semicolon. Java doesn't do a good job of reading spaces and carriage returns. So we need to put semicolons at the end of every functional line of code, for the same reason that a Morse code operator would send the message stop at the end of every line. Now, NetBeans has become a little more satisfied. The jittering has decreased, but there's still something wrong. The issue is that functions in a programming language, just like files on a computer, have a location where they exist. NetBeans isn't sure where to find the function println that we've attempted to use. So we simply need to tell NetBeans where this function exists. The full path to the println function is system.out.println. Let's get rid of these extra spaces I created there, not because they would affect the way our program runs, just because it doesn't make it look quite as nice. And now we've written our Hello World program. So what do we do with this? Well, as we know, our computer can't read this Java code directly. It must convert it into a computer-readable language. So, executing this code becomes a 2-step process. First, we're going to ask NetBeans to build our project. This means that all of the code within our project will be compiled and converted to computer-readable code in a, essentially, computer-readable project. When we press the build button, we'll see a bunch of text in our output box down here, and hopefully this nice build successful, and then the time it took to build the project. Once we've built our project, we can press this run button right here to execute our code and our println statement. NetBeans will then give us this pop-up box here. When you execute a program outside of an IDE, you execute it by launching one of its executable files. Because we're in an integrated development environment right now, NetBeans wants to be sure which of our files we would like to be the entry point of our program. We only have one option here because we've only written one Java class. So let's confirm for NetBeans that Hello World is our main class, and the main function in Hello World will therefore be where we start executing our Java program. Then when we hit OK, our output box will tell us the program has begun to run, and our program then prints Hello World to the output box as we intended. And there you have it. Now we're Java programmers. Of course, there's more than a little bit left to learn. In fact, Hello World in Java is probably the scariest program you'll ever write. Java is extremely powerful, and the reality is we simply can't hope to appreciate all of its intricacies while writing our first program. The really good news is that from this point on, we need to take far fewer leaps of faith, and we can begin to build a very solid understanding of Java by taking a step-by-step approach. I'll see you next time.